Hello everyone and welcome back to another project. In this project I'm going to show you on how you can make the weather monitoring drone or the aerial weather station. So initially I'll be talking about the features of my project and some of the technical aspects. Then I'll be describing the components that I've used here, and finally I will be showing the real-time demonstration the way the project works. So with no delay I would like to dive into the features and few of the technical aspects of my project. So it's an addition or an upgrade to my existing drone where I have designed this bottom plate with all the circuitry, with all the components required for monitoring different weather parameters like the air temperature, the air humidity, the atmospheric pressure, the altitude, and the percentage of gas at different atmospheric levels. So this bottom plate has to be attached with the landing gear of my drone, and as we fly the drone at different atmospheric levels, we'll be able to monitor the atmospheric composition or the weather parameters at that certain location. So all you have to do is simply attach this bottom plate with the drone and then fly the drone to get the weather parameters. Now, the monitored weather parameters, the 4 or 5 parameters that I've already told you, all these pointer parameters must be shared with the user in real time, and there are a number of approaches to do so, and I've followed the GSM based approach where you simply have to send an SMS to the GSM module, to the SIM card which is inserted to the SIM 800L GSM module, and then the SIM 800L GSM module will be sending you back all the monitored information of that time, like the air temperature, the air humidity, the pressure, atmospheric pressure, the altitude, and the presence of gas or the percentage of gas at that atmospheric level. There are a number of few more approaches that you can follow in order to transmit the weather parameters between the user and the drone. For example, you can follow the IoT based approach where you can design an IoT dashboard, and the ESP32 board would be connected with a Wi-Fi network to share all this information, to update all this information onto the IoT cloud or the IoT dashboard. But the problem is the ESP32 board must be connected with the internet. So in order to serve that purpose, all you can do is simply use a pocket router and then attach the pocket router on top of the board and connect the ESP32 board with the pocket router having internet connectivity, and following this way you can easily update all this information to the IoT cloud, to the IoT dashboard, and it doesn't have any kind of limitations, range related limitations, as long as the router would be attached with the board. So as long as the network like the 3G or the 4G network is available, then the pocket router would be completely functional, and you would be able to monitor all this information in the IoT cloud dashboard. But for now I don't have any kind of pocket router, so I couldn't proceed with the IoT based approach. So there is another approach that you can follow, which is by using the NRF transceiver making a ground station. So what the NRF transceiver does is that the transmitter has to be attached with the top of the board, and the transmitter of the NRF module will be transmitting the weather parameters to the receiver, where the receiver is another NRF module that will be situated in the ground, simply known as the ground station. But this one has a range related limitation because the NRF transceiver doesn't work at a range of more than 800 meters. So as you are using, so if you use the NRF module, the NRF transceiver, then you will get a range of at most 800 meters. So among all these, based on the availability of components and making the things more compact, lightweight, which is another important part, so that the drone can fly with the least amount of thrust as possible, consuming lower power, I had to go on with the first approach, that is by using the GSM module. As you can see, the SIM800L GSM module, the red one, which is very compact, small in size, and very lightweight. So this was one of the best options for me to proceed with for designing the weather monitoring drone. So as I've already told you, you simply have to attach this bottom plate with the drone and then fly the drone to different atmospheric levels to analyze the atmospheric composition. So I believe I'm done with the features of my project and the technical aspects as well. So right now I would like to dive into the description of the components that I've used here. So I'm going to paint. So as you can see, this is my bottom plate that is to be attached with the landing gear of the drone, and right now I'm going to talk about the components that I've used here. So first of all, as the microcontroller, I have used the ESP32 board. As you can see, all right, let me adjust the pen. Yes. So as you can see, as the microcontroller, I have used the ESP32 board over here. So the ESP32 board comes with a built-in Wi-Fi, even though I don't need the built-in Wi-Fi, and it's very cheap and it's very small and compact in size. So it was really a good option for me, as I had space-related limitation as well, weight-related limitation. So I went on with the ESP32 board, other than the existing Arduino boards or the STM boards. So as the microcontroller, as I've already told you, I've used the ESP32 board, which is very compact and lightweight. And to monitor the temperature and humidity, I have used the DHT11 temperature plus humidity sensor module. To monitor the atmospheric pressure and the altitude, I have used the BMP180 module. As you can see, that comes with a number of features, but for this part of the project I have only used the atmospheric pressure and the altitude. For monitoring the composition of gases, for monitoring the percentage of gas at different atmospheric level, I have used the MQ2 gas sensor over here, as you can see. But the MQ2 gas sensor, remember one thing, that consumes a lot of power, so you must ensure that your power supply is capable enough for supplying all these components along with the MQ2 gas sensor, as MQ2 gas sensor consumes a significant amount of power, I should say more power than the other components existing here, as you can see on the breadboard. Then, in order to transmit the weather related data, the weather related information to the user, I have used the SIM800L GSM module over here, as you can see. So it's very cheap, lightweight and very small, as you can see, which was really a very good option for me to go on, as my objective was to minimize the size of the entire board, as well to reduce the weight, so that the drone can fly with the least amount of throttle, with the least amount of thrust, giving me additional flight time. So now let's talk about the power supply unit. So I have used this pair of batteries to this pair of 3.7 volt lithium ion batteries to supply all these components except the SIM800L GSM module. So this pair of batteries will be supplying all the components except the SIM800L GSM module, but this pair of batteries generate around 8 volts, but all these components are 5 volt tolerant. So I had to step down this 8 volt generated by this pair of lithium ion batteries using the LM7805 linear voltage regulator, and the output has been output of the LM7805 linear voltage regulator has been fed to the ESP32 board, to the BMP180, to the DHT11 and to the MQ2 gas sensor. Now, another important part that I would like to tell you is that the analog value that the MQ2 gas sensor gives us, the maximum value will be 5 volts. So if you go through the ADC or the analog to digital conversion, you will get at most 5 volts, but the analog pins or the digital pins of the ESP32 board are 3.3 volt tolerant. So there might be some kind of ambiguity in the smoke levels in the data. So to avoid that, I have used a linear voltage regulator, as you can see over here, with this pair of resistors. So let me make the picture a bit clear. You can see a pair of resistor over here. One is 100 ohm and the other is 200 ohms. So this is a voltage divider circuit that has divided the 5 volt output, the maximum 5 volt output of the MQ2 gas sensor, and I've taken the output from I've taken the voltage, the analog voltage, from the 220 ohm resistor, which is right over here. So this one is 220 and this one is 100 ohm resistor. So I've taken the output from 220, that gives us an equal division of two-third division. So corresponding 5 volts, we get a maximum voltage of 3.3 volt that satisfies the requirement of the ESP32 board. So this is the reason I've used this voltage divider circuit, connecting in series a 220 ohm resistor and a 100 ohm resistor. And the SIM800L GSM module requires very stable power supply, and you cannot supply it with the with 5 volts. It may happen that the device may get destroyed if you are supplying with 5 volts. At most you can supply 4.2 volts. So I've used a completely charged lithium ion battery, as you can see over here, in order to power up the SIM800L GSM module. It's very important to remember that the SIM800L GSM module requires very stable and constant power supply, otherwise it will not work properly. And if the LED, the indicator LED on the SIM800L GSM module blinks once in every 3 seconds, then that would be a clear indication of the fact that the device is established on network. But if it is blinking once in every second, then it means that it has failed to establish with the network. There might be issue with the network, or there might be issue that happens in most of the cases with the power supply. And you can't use any kind of jumper wires to connect to supply the power to the SIM 800L GSM module for junction capacitance, for junction capacitance issues. So for this reason, the 4.2 volt that I've supplied to the SIM 800L GSM module, I have supplied it directly without using any jumper cables, because the top of the jumper cables, they are clamped using mechanical junctions. There is no solder rings on these caps of the jumper wires. So it eventually generates junction capacitance or disruption or discontinuity. A little bit of discontinuity might be in milliampere or in microampere range, that eventually hinders the constant or stable power supply to the SIM 800L GSM module. So for this reason, ensure that you supply directly the SIM 800L GSM module with a single cell lithium ion battery, and the battery must be completely charged. If it is going below 3.7 volts, then it's likely possible that the SIM 800L GSM module will not be working, or it may fail to establish on the network. In other words, you can also design a PCB that will make the entire structure more compact, and in that case you won't have any kind of junction capacitance issue, and the SIM 800L will be running very smoothly without any discontinuity in power supply or network connectivity. So that's all about the components that I've used here. Make sure that the bottom plate, I've used a cork sheet over here which is very lightweight. So whatever you're using, make sure that it's capable of taking the load of all these components, and arrange the component as such the weight is distributed equally. And one more thing, try to make it as compact as possible, as much lightweight as possible. In order to straighten the bottom plate, that is the cork sheet that I've used here, I have used some glue with this around these holes to straighten its mechanical stability, and I've used these scotch tapes, as you can see, just to give it more mechanical support. So that's all about the components that I've used here. I will be attaching this bottom plate with the landing gear of my drone, with the legs of my drone, with the anti-skid legs of my drone, using these ropes, as you can see, at the corners, and then I'll be flying the drone, and shortly I'll show you the demonstration, the way the project works. So right now I'm on top of my rooftop, on top of the 9th floor, from where I will be showing you the demonstration of the aerial weather station, or in other words the weather monitoring drone. So that's how the final structure looks like after attaching the bottom plate with the drone. As you can see, I have the bottom plate attached with the drone. You can see the breadboard having all the circuit components assembled on it. You can see the SIM 800L GSM module. It's blinking once in every 3 seconds, which is a clear indication of the fact that it's completely established on network. And you can see the other components, they are also powered up correctly. I have the single cell here that will be powering up the SIM 800L GSM module, and towards the end I have the pair of lithium-ion batteries that will be powering up the entire circuitry. So right now I'd like to hand over the camera to my brother, who will be assisting me to record the video and the demonstration in other words. So as I send the SMS data to the drone, to the SIM card, to the GSM module, which is attached with the bottom plate of the drone, then it will be sending me the weather information, all the parameters of weather information, like the air temperature, humidity, the gas level in the air, the pressure, the altitude, and so on. So I'm handing over the camera to my brother. Watch out your fingers. So right now I'm going to arm the vehicle and take off shortly. So I'll be arming the vehicle. So I believe that the safety switch has been pressed. If not, then let me press. Yes, the flight mode is loiter, and I'm arming the vehicle. So the vehicle has been armed, and I'll be taking it off shortly. As you can see, it's taking off. It's a bit heavy, so it requires more thrust to achieve an altitude. So the sunshine is very high. I can barely look at the sky with the eyes open. So I believe you can see the drone. Let me increase the altitude a bit more and displace it from its home location a bit. keep the drone to the right of the video frame. So I believe you can see the drone quite clearly. Right now, I'm increasing the altitude a bit more. And right now, I'll be sending an SMS. Right now, I'll be sending an SMS to the drone uh, for, for the weather information. Let me get it a bit more forward. Okay. I'm spacing it a bit more. Yes, fine. Okay. So right now, I'll be sending the command data from my cell phone. From my cell phone, I believe you can see my cell phone. Maybe not that much clearly. Get it here. I believe you can see my cell phone. So I will be sending the command data from my cell phone. Make sure that it's visible on the screen. Yes, I believe you can see that I'm sending data command from my cell phone. So yes, it's been sent. Let me wait until it's being delivered. Yes, it's being delivered. So I'm waiting for the SMS back. That will be, yes, as you can see that I have an SMS which has arrived at 9:52 a.m. and right now the time is 9:52, as you can see, and it's telling me about different parameters of weather, like air temperature, which is 32.3 degrees Celsius, the humidity level, the air pressure, the altitude. Maybe the unit of the altitude is not correct. I have to fix it, and the smoke level. So the smoke level is showing 254%. Maybe something's wrong with the smoke sensor. Maybe it's not powered properly. Otherwise, it would show a better result, I would say. So let me send once again and check what it sends me. So focus on the drone meanwhile. So let's wait for the SMS back. Meanwhile, the camera is focused towards the drone. Yes, I have received an SMS back. I have received an SMS back with all the information, as you can see, with all the weather parameters. But the smoke level is being a bit ambiguous. The reason behind this is maybe it's lacking from power. Maybe my batteries are running short of voltage. So right now I'm done with the weather information. So I'd like to land the vehicle right now. So I will be getting it down. Instead of the RTL mode, I will be landing the vehicle manually. So I'm getting the vehicle down. The wind is very high, and some of the high low. Vehicle is coming down, and a smooth landing. So that's all for now. I hope you liked it. Thanks for watching. Stay tuned for the next one. Bye for now.